Hello and welcome back to another maths video, and this one I'm going to be doing the summation. So first I'll start off with some examples of simple summation. So we have class and we have a class total. And we have the questions, so pupil 1 scored 23 on question 1, pupil 2 26, and so on. The class might be a bit bigger. So how do we want to know the class total? Well, it's the sum of question 1. So all this data in question 1. For question 2 it's the same thing, just for all the data in question 2. Looks like people 4 didn't do so well on this one. Although I did put the input, I inputted the data. But they were random-ish. And another example, two examples would be, first of all in statistics, use summation. And the second one is in endothermic and exothermic reactions. And the delta H in a graph showing endothermic and exothermic reactions and activation energy and all that kind of stuff is created by the sum of the energy for the made bonds, the created, the products, subtracted the sum of all the energy required to break the reactance bonds. Moving on. So I have some steps. So I have step 1, flat path, step 1 and 2, step 1, 2, 3, 1, 2, 3, 4, and the green is the nth term, so the term we're on. So this is the first term, second term, third term. And as you can see, this term is just simply n, because there is no difference between the highest number in the amount of steps and the term. In all of them, that is. The red is for the total amount of steps so far. So we're going to put our sum sign. Summing n. Well, what is n? Well, n starts at 1, and that's the first term. N starts at the first term. Then it increments by 1, which is what it does, every time up to, let's say, 5. So this is our beginning point, this is our end point, and this is our rule. So we plug 1 in, 1 into n, where n equals 1. What's our answer? 1. Plus, because it's summing, now we go up, we increment 1 by 1, that's 2. Put n equals 2, put it into this equation, n plus 2. And we do this all the way up till we reach 5. We put 5 into the equation, and then we get plus 5. And this would normally be written out, though, as plus, and then you write the rule. So here it's n. So if we could move on, I'm going to give some examples. Maybe you can calculate them. So quickly pause the video, you get a pen, paper, possibly a calculator. Probably a calculator. If you've never done summation before, or if you don't know the rules. For the first two, I'm going to give you 10 seconds. So 3, 2, 1, go. Are you done? Oops, wrong one. Did you get the answer of 55? Let's try the next one. This time again, 10 seconds. 3, 2, 1, go. Stop. Oh, I don't know this one off by heart. I'm gonna have to do some methods. Oh yes, I do. This one is 66. Okay, this next one I'm gonna give you a bit more time on. Maybe I'll bring it up to 15 seconds. 3, 2, 1. Stop. Did you get 210? Let's try a bit more difficult ones. I'm going to give you, again, 15 seconds. 3, 2, 1. Oh, sorry. Did you get 110? Remember, the rule was 2n. So that means you plug 1 in, and then it's 2 times 1. Plus, you plug 2 in, 2 times 2, 3, and so on. Next one, 3, 2, 1. Stop. Was the answer for this one 132? Let's see how you worked them out. Did you manually add them all up? Or did you use a rule like I did? You see, honestly, the only ones I actually knew off by heart is this 10 with the rule of n, and this 11, I remembered it. The rest I had to do calculations for. So let's try something a bit different. Say we have from 1 to any number with a rule of n. How do you think we're going to go about and work that out like I did? Well, we're going to take k, or the ending number, and we're going to square it. We're going to add itself, and then we're going to divide by 2. Now notice how this part can be taken out and turned like this with brackets. Factorization. K times k plus 1. Let's try the next one, and I'll erase all the ink on here. So, going from any number to any number following a rule of n. How do we come about working that out? Well, not sure if you might have guessed, or maybe you might work it out if you pause the video now. You take k, square it, plus k, divided by 2. Nothing different except for this isn't 1. But, you see, the big but is, you could do the exact same as from 1 to k with the same rule, minus from 1 to x. So if you get that, it will be, with the same rule, then you can see that you will get the same answer as manually. So if you did 3 to 5, it would be 3 plus 4 plus 5. 3 and 4 is 7, plus 5 equals 12. Now let's do it this way. 5 and 1 to 5 is 5 squared, which is 25, plus 5, which is 30, divided by 2, which is 15, minus, so that's 15, minus, from 1 to 3, well, don't have to do all this calculation, it's really easy, 1 plus 2 plus 3. But wait, it isn't. Because then you're including this one into the equation. It's actually this number minus 1. You see? So, then it would be 1 plus 2. So, minus 3, sorry. And there we go. They equal each other. So, if we're going to have to write this out in an equation, it will be the same, yes. It will be basically k minus, no, n, sorry, minus, and from 1 to x, minus 1 with the rule of n. And all you have to do is pretend that this, so you ignore this, and just pretend this is one of these. So then it will just be minus x minus 1 squared plus x minus 1. Also, x minus 1 squared is, let's get rid of that 2. We can turn it into a quadratic if you remember what quadratics are from last episode. So x and x is, sorry, 1 second. I'm gonna sneeze. Okay, I'm fine. So x and x are x squared, negative 1x, negative 1 and x is negative x, negative 1 and x is negative x, that becomes negative 2x, and negative 1 and negative 1 is positive 1. Then we get x squared, negative 2x plus 1. Plug it into here, so plus x, sorry. I remember the equation, don't worry. X squared, negative 2x, positive 1, positive x, negative 1. These ones cancel out, and then this 2 cancel out with the x. So then we just left with x squared negative x divided by 2 as the end. So I think my mic just went mute. But you probably remember the rest, so I'll just leave that back up there. And that isn't what it equals, it's this minus. So it's k squared plus k divided by 2, and then it's this over here. And then, now we're going to go for some more ones. I'll write this all back later. So if we wanted to do this, then just for this one, this doesn't work with any other. I've just found this works with this one. It's just times 2, so we take the same equation again. K squared plus k divided by 2 times 2, the 2's cancel out, and we're just left with k squared plus k. And then we go back to similar equations like this, and so we just do times 2 each time, and so we're just left with k squared plus k minus x squared negative x. But if we do that, then this actually equals, I've just seen this now, k squared minus x squared plus k, and then these two come together and we get plus x. I don't think that's going to work if we put that back in with our 3 and our 5, but I'm going to try it. 5 squared minus 9, so 25 minus, 25 minus 9 plus 5 plus 3. 5 and 3 is 8, so it's basically minus 1, which is 24. Nope, doesn't work. Just going to have to leave it how it is. As just like that. Ish. Maybe not even like that. X squared. Oh, sorry, it's a plus. You've probably been shouting that at me if you've been paying attention. So, it's a plus, right? So then it does become negative and all that kind of stuff. Alright, don't worry, don't listen to me. I did badly. So it would be 25 minus 9 squared. And just don't worry. I'm doing so badly at this. Just to recap. This is your ending number, this is the summation, sigma sign, this is your starting number, this is your equation, function / rule. And yeah, as long as this equals just x, as long as f x just equals x, which by the way is used in graphs, so then that just means y equals x. It's just if you have something like y equals 4x squared minus 3.6, and you wanted to divided by 2x, and you wanted to put something in x, then you could just give this f x equals, and then you just put whatever value you want x to be, so I don't know, like 2, and then it will become 4 times 2 squared and minus 3.6 divided by 2, which is basically 2 squared. So let me just get the scientific out. 4 times 2 squared is 16, 4 squared basically, minus, so 16 minus 3.6 divided by 4, 3.1. So there we go, y would equal 3.1, and so would f, wait, this number was 3, right? No, 2. So if we put f 2, then that would equal 3.1, which would equal y. But that's for another video when we do like integrals and stuff. So yeah, thanks for watching. like, subscribe, and leave a comment. Bye!